Welcome to The Explainer. Okay, I want you to imagine, just for a second, a machine walking into your house. And I'm not talking about a little robotic vacuum cleaner bumping into your walls. I mean a machine that can literally walk into your specific kitchen, figure out where you keep the mugs, find the coffee beans, operate the tap, and successfully brew you a fresh cup of coffee. It sounds like a super mundane morning chore, right? But to a computer scientist, this right here represents the absolute holy grail of technology, because doing that requires a level of human-like understanding, adaptability, and real-world reasoning that completely eludes the software we use today. We're talking about the ultimate pursuit of thinking machines. What I just described is actually the famous Apple co-founder Steve Wozniak's coffee test. And honestly, it's brilliant because it takes this incredibly complex, highly abstract scientific goal, creating an artificial mind, and grounds it in a totally relatable, everyday challenge. To make that coffee, a machine can't just run on some rigid code. It has to actually understand a dynamic environment, solve unforeseen problems on the fly, and adapt. And that adaptability, that is the very core of what we call AGI. Okay, let's dive into this. First, we'll cover an introduction to general intelligence. Then look at the history of AGI, see how experts are defining and testing it, weigh the impact on society, check the current status, and finally, we'll explore the future outlook. So, Section 1, Introduction to General Intelligence, Understanding the Ultimate Goal of AI. There is a pretty stark contrast between the tech we have right now and what we're actually trying to build. Today, we live in a world of what's called narrow AI. Now, these systems are incredibly competent, sure, but they're strictly confined to really well-defined tasks. Think of IBM's Deep Blue beating a grandmaster at chess, or AI models that predict protein structures. They are absolutely superhuman in one specific domain, but they literally cannot learn a completely new task outside of their original programming. Artificial general intelligence, or AGI, on the other hand, is a whole different ballgame. It represents a system that can generalize knowledge, transfer its skills between completely different domains, and solve entirely novel problems, basically just like you and I can. But here's the wild part. The theoretical ladder doesn't actually stop at human-level intelligence. Beyond AGI is something called artificial superintelligence, or ASI. If AGI is an artificial mind that basically matches the average capabilities of a human being, ASI takes it a massive step further and drastically exceeds our limits across literally every single domain. We're talking everything from artistic creativity to quantum physics. It's the kind of concept that really forces us to pause and question, well, what exactly happens when we are no longer the smartest entities on the planet? Moving right along to Section 2, the history of AGI, from early optimism to modern breakthroughs. Let's move to and see how this builds across the timeline. Back in 1950, Alan Turing fundamentally shifted computer science by proposing a test for machine intelligence. Fast forward to 1956, and the term artificial intelligence was officially coined at the Dartmouth Conference. Now, those early researchers, they were wildly optimistic. I mean, some of them genuinely predicted human-level AI within 20 years. But by the 1970s, reality hit, and it hit hard. Researchers realized they had totally grossly underestimated the sheer complexity of the human mind. Funding dried up, and that ushered in what's known as an AI winter. But specialized computing eventually bounced back. We saw narrow AI victories like IBM's Deep Blue in 1997, and more recently, the massive explosion of large language models like GPT-3 in 2020. And that brings us to today, where the AGI dream has been completely reignited. Which brings us to Section 3, Defining and Testing AGI. Basically, how will we actually know when we've reached it? You see, the big challenge right now is that there is actually no single universally agreed-upon definition of intelligence. So, researchers have proposed a bunch of really fascinating benchmarks over the years. You've probably heard of the classic Turing test, which involves a machine trying to convince a human judge, through text, that it's also a human. But today, a lot of experts heavily criticize it. They argue it mostly just measures how easily humans can be fooled, which is a psychological phenomenon known as the ELIZA effect. So, to fix that, we have more physical tests, like the IKEA test, where a robot has to autonomously assemble flat-pack furniture just by looking at the parts. Which, let's be honest, is a test a lot of actual humans would fail. Then, of course, there's Wozniak's coffee test we talked about earlier. And finally, there are tests that focus entirely on real-world, hard economic value. And that brings us to this pretty staggering number right here. Mustafa Suleyman, the co-founder of DeepMind, proposed a very modern test for AGI. The challenge? Give an AI model $100,000 in seed capital and tell it to turn that into $1 million, entirely autonomously. Crazy, right? To pass, the system would literally need to invent a product, interface with human manufacturers, run marketing campaigns, and manage all the finances. It's designed to test complex, open-ended, multi-step tasks in the messy real world. Now, while most current AGI research is super focused on neural networks and language models, there's another deeply fascinating technological path out there called whole brain emulation. The core idea is simple, but technically it is just staggering. You would scan a biological brain in incredibly high detail, map out the hundreds of trillions of synaptic connections, and then simulate that exact physical structure inside a supercomputer. Because if human intelligence comes from the biological brain, this approach attempts to literally reverse engineer our biological hardware straight into software. It's mind-blowing stuff. All right, moving to Section 4, Impact on Society, covering the monumental benefits and the existential risks. And this brilliantly illustrates the massive duality of this technology. On one hand, we could supercharge scientific discovery, model incredibly complex solutions to the global climate crisis, and completely revolutionize medicine by drastically accelerating drug discovery and creating truly personalized healthcare. But on the flip side, we are hearing stark warnings from major industry leaders and top researchers. There are very genuine concerns about a complete loss of human control. You know, the idea that an intelligent system might naturally start seeking power and resources just to achieve whatever goals it was originally programmed with. We also face the very real threat of mass technological unemployment, plus the risk that AGI could be used to entrench totalitarian surveillance. It is a massive spectrum, literally carrying the highest possible stakes for humanity. The late great physicist Stephen Hawking actually had a profound insight on this. He pointed out that automation itself isn't inherently evil. Rather, the ultimate outcome is going to depend entirely on human governance. He noted that if machines produce massive wealth and do our labor for us, humanity could potentially enjoy a life of unprecedented leisure. But if that wealth is hoarded by the entities who own the machines, it could drive a wedge of extreme, miserable inequality. And that right there is exactly why you hear figures in the tech space constantly debating things like universal basic income as a potential absolute necessity in a post-AGI world. Now, Section 5, Current Status and Timelines. Are large language models already AGI? So there's an intense, ongoing debate right now in the computer science community. The optimists out there look at state-of-the-art models and see what some researchers are literally calling sparks of AGI. They point out that a single model can now write complex code, translate multiple languages, easily pass the bar exam, and analyze complex images, all of which shows a really high level of general capability. But on the other hand, we have the skeptics, folks like Meta's chief AI scientist Jan LeCun, who argue that these models are essentially just really good at predicting the next word in a sequence. They argue that language models fundamentally lack true common sense, they have absolutely no physical embodied experience of the real world, and they definitely cannot engage in reliable hierarchical planning. But honestly, regardless of whether today's AI is officially classified as general intelligence yet, the disruption is absolutely already here. Just take a look at this data from an OpenAI research paper. It estimates the impact of current large language models on the US workforce. They found that while 80% of workers will see at least a minor impact on their daily tasks, a full 19% of the workforce could see at least 50% of their daily tasks impacted by the AI that is already sitting on our computers today. Office workers, mathematicians, accountants, they're noted as some of the most highly exposed. The big takeaway here, this economic shift doesn't require us to sit around waiting for full AGI. It could literally be impacting your daily workflow right now. Finally, we arrive at Section 6, the future outlook. The big question, when will AGI actually arrive? So the crucial point is how rapidly expert timelines have shrunk in just the last couple of years alone. I mean, historically, experts placed AGI 50, maybe even 100 years away, but not anymore. In 2024, NVIDIA's CEO Jensen Huang flat out stated that AI could pass any human test within just 5 years. Leopold Aschenbrenner, a former OpenAI researcher, is calling AGI by 2027 strikingly plausible. Broader surveys of AI researchers currently center their predictions around 2040, and get this. A massive survey of over 2,700 researchers predicted that unaided machines will outperform humans in literally every possible task by 2047. The finish line is moving closer, and it's moving fast. To wrap up this explainer, I want to leave you with this really provocative thought, once again from Stephen Hawking. He famously compared the impending arrival of superintelligent AI to receiving a message from a superior alien civilization. His point is chillingly clear. We are actively building an entity that could be vastly, unimaginably more intelligent than we are. And according to the timelines, it's scheduled to arrive in our lifetimes. So the question we all need to deeply ask ourselves is, are we truly doing enough to prepare for when it lands?